Miss Guzman. Any idea about process control, process dynamics and control? There are 3 significant words. Ano yung context, kumbaga, ng process dynamics and control sa tingin nyo? There's no wrong answer here. Gusto ko lang malaman kung ano yung tingin nyo sa process dynamics and control.
More on designing ba, sir?
Designing. Somewhat, but it's not the real focus. How about si Rowan? Yeah. Miss Ramiscal. You can raise your hands. About si Mr. Manuel. What do you think about process dynamics and control?
Sir, yung process nangyayari sa isang industry, for example, paint industry po na nagwo-work sa multidisciplinary team or ganun po.
Okay. Alright, so from the word process dynamics, okay, dalawa yung mabubuo natin dito. It can be process dynamics and process control. When we talk about process dynamics, okay, it is the change of the process over time. That's the word dynamics. Okay, and process control, it is for you to control the process. Okay, the more you know about the process, the more you know about the dynamics of the process, the more you can gain control to it. Okay, kasi kung minsan or madalas, every process ay may ginagawa, right? Parang ginagawa ang process, right? So, over time, nagbabago yung mga nandoon. And we chemical engineers, we need to control that. Kung tao lang kasi ang magko-control sa dynamics of the process, medyo mahirap. Okay? It may be impossible for us to fully control the process kung wala tayong process control system. That's why we need to study process dynamics and control in order for us to design a system to automatically control the process. That's the context of process dynamics and control. Okay, so in this lecture, we will talk about what process dynamics and control is about. Second, we will have determine the reasons why chemical engineers need to control the process. 3, the incentives of chemical process control. And 4, design aspects of process control system and some terminologies na kailangan nyo ma-familiarize in order for you to better understand or in order for you to dig deep sa process control. Okay? So what is process control? Process control is the study and application of automatic control in the field of chemical engineering. The primary objective of process control is to maintain the process at desired operating conditions, safely and efficiently, while satisfying environmental and product quality requirements. Gets nyo yun? Okay, meron tayong process control kasi gusto natin na ma-achieve ang desired na concentration ng ating product or any process na gusto natin na ganito ang kinalalagyan. Okay? We need process control. We are to, kumbaga, understand and then i-control ang process without much human intervention. So, kakailanganan natin ng automatic control. When we are to design automatic control, we need to anticipate yung mga disturbances. Ano bang mangyayari kung ito yung gagawin? Ano bang mangyayari kung ito yung papasok sa process ko? Ganon. Kailangan yung i-anticipate in order to control the process, to automatically control the process. Okay? So for example, we have a reactor here. Example, this is a exothermic reaction. When we say exothermic reaction, anong nangyayari? Miss Malabo, in terms of heat, in the context of heat,
Nag-a-absorb
anong
po ng
nangyayari?
sir.
Nag-absorb ng heat. Tama ba siya, Miss Nepomuceno? Tama ba? Or Mr. Devon, tama ba na nag-absorb ng heat ang exothermic reaction?
Sir, nagre-release po ng heat sa surroundings po.
Yes. Okay. So, Miss Malabo, from the word exo, you release heat. Okay? This is an exothermic reaction. For example, reactant A forms product P. Okay? In this product, heat is released. Okay? That is exothermic reaction. For example, we have a reaction going on inside here, inside this reactor. Okay? May reaction dyan. Over time, as we produce a product, okay, the temperature inside the reactor increases. Okay, as we feed reactant A, okay, and we produce product, the heat inside the reactor increases. That's why most reactors na exothermic, meron tayong ini-install na water jacket. Okay? Pero since continuous ang imagine nyo kung ang reactor or yung jacket ng reactor na water ay stagnant lang yan. Okay? Parang walang supply, walang in or out. Kung ano yung initial na laman ng water jacket, yun na yun. So, do you think you can regulate the temperature inside the reactor? Hindi. Okay? So, we have to introduce a continuous supply of cooling water. Ang ginagawa ng process control, since the objective here is to control the temperature, this is the control objective. Okay? To control the temperature inside the reactor. So, ano ba yung mga in-anticipate natin dyan to control the temperature here? In-anticipate natin that this is an exothermic reaction. And as we produce product, and as we introduce a feed, the temperature inside the reactor increases. Okay? And we also anticipated the cooling water must be continuously supplied in the reactor jacket. Okay? So, if we are to control this, we need to introduce a control system design. So, anong nangyayari dito? So, your TT here, this is temperature transmitter. This is your temperature transmitter na mine-measure niya yung temperature, the actual temperature inside the reactor. Okay, so alam niya na ang temperature dito. For example, we have 200 degrees C ang temperature. Okay? Itatapon niya dito sa, kumbaga, bago yung controller, tatapon niya sa controller, sasabihin niya sa controller na mataas yung temperature. Pero paano man sasabi na mataas yon? We need to set a set point. For example, ang set point natin na temperature is just 100 degrees C. So, ang gagawin nito, i-compare niya yung actual na temperature inside the reactor, okay, doon sa set point na sinabi natin. So, ang controller naman, since naka-decide siya based on the difference here, na kailangan niya i-maintain ang temperature inside the reactor is just 100% dapat. Okay, ang gagawin niya, ipoprompt niya itong valve of the cooling water to increase the flow rate of it so that the temperature inside the reactor is regulated. Ganun ang process control. And walang masyadong human intervention, right? Ang ginawa lang natin, naglagay tayo ng set point. Yung controller na yung nagtrabaho doon. But of course, without the temperature transmitter, hindi rin natin malalaman kung ano yung actual temperature inside the reactor. Okay? 200 yan. For example, 200 na yan. And then, kinontrol ni controller yung valve dito, increasing the flow rate of the water. Pinapalamig niya ito. Okay? Of course, habang pinapalamig niya yan, malalaman nung sensor kung ilan na lang ang temperature niyan hanggang sa maging 100 siya. Okay, so this is a glimpse of a control design. Okay, a control system, I should say, for the process of controlling the temperature inside the reactor. Okay, assuming that this reactor reacts reactant A to product P. And this is an exothermic reaction. So, ganun ang process control. Okay? Ito ang example of a control system. Okay? And we might talk about more about this. This is an example of feedback control system. Yung feedback control system, papag-aralan natin sa higher level na subjects later on. Okay, this is an example of feedback control system. Feedback kasi, na-disturb na muna yung system. Na-upset muna siya bago siya aayusin. This is a feedback. So, if you feedback dito, nung temperature transmitter na yung temperature sa loob ng reactor ay upset na. So, meron tayong product na 200 degrees C. So, meron tayong undesired na product. Okay, that is one of the disadvantage of a feedback control system. Kailangan mo nang ma-disturb, kailangan mo nang masira yung system or hindi makuha yung gusto natin bago natin to aapulahan. Okay? And of course, there is what we call feed-forward control system. Yun naman ay in-anticipate na natin na may disturbance. Okay? So, before pa siya pumasok sa system, sa process, ay okay na siya. Ay ganun ang pagkakaiba. But anyway, that is a topic for next time. Okay? Sinabi ko lang. So, kung galing kayo sa industry kasi, okay, these are the representations of process control. Okay? For example, if this is for example, this is a composition of distillate. Okay? Yung line dito sa gitna, okay? Yung line dito sa gitna, that is what we call the set point. And ito yung change of the composition over time. So yung fluctuating talaga siya, parang hindi siya na-standardize. So parang kung i-compare mo ito sa product niya, talagang upset yung system. Wala tayong magandang product na na-produce. And it is what we call mediocre control. Okay? We can say that it is a better control if we have eliminated the variabilities. If we have eliminated the fluctuations here, naging maliit lang siya and malapit siya sa set point, it is what we call a better control. Improved performance naman kung kaya natin na ilipat ang set point kahit saan at sumasama yung mga fluctuations. Sumasama siya malapit sa set point na gusto natin. That is improved performance. Okay? Nung nag-work ako as shift supervisor nung nasa Kabuyaw ako noon, ang ginagamit lang nila is Excel. So every day, every hour of 12-hour na shift, chine-check namin yung pH nung reactor, ganun. And alam natin that when we are to treat a wastewater treatment or wastewater, okay, and we use the idea of coagulation and flocculation, we are to maintain a range of pH in order to coagulate or flocculate, right? We have a 6.529 na pH yan. And those are the limits. For example, we are to graph that. Okay. This is the pH sa Y. So upper limit is 9, lower limit is 6.5. This sa x-axis natin will be the we have the time. Okay. So every hour for 12 hours, chine-check namin kung ilan ang pH. So kung i-graph natin 'yan, kung nandito ba siya sa range na gusto natin or lumagpas siya sa range na ayaw natin, bumaba sa range na ayaw natin. Okay? So we can see the fluctuations. It can be a representation of process control. Kung na-control mo ba talaga o hindi. Okay? Any questions so far? May question ba? Before we move to the incentives for chemical process control. May question ba? Hello? Okay, so we move to incentives for chemical process control. First is safety. Okay, when we control the process effectively, we can also ensure safety. For example, dun sa reactor, when we don't have a full control of the exothermic reaction going on inside the reactor, mag-overheat yun, it can cause accidents sa mga personnel. Okay, so we give that incentive to process control. Okay? Next is product specification. Okay? Since it is automatic and we have designed the control system based on anticipated disturbances and anticipated disturbances, we can ensure product specifications based on what we have desired. Okay, so that's an incentive for chemical process control also. Next, of course, is environmental regulations. Especially when you will be working on sa mga industries that treat wastewater, okay? May mga industries kasi that they're mostly yung wastewater nila ay may mga heavy metals, okay? Yung mga electronic companies, yung mga nagpro-provide ng mga pang-electronics na parts, okay, madami silang heavy metals sa wastewater nila at hindi nila dapat itapon yun as is. They need to treat that based on the standards of the government. Okay, standards of effluent. Okay, yung effluent na dapat lang lumalabas. Okay. Next, we can also minimize operational constraints. May mga, since sabi ko nga, we have already anticipated disturbances, operational constraints are minimized. And 5, okay, yung economics ay effective. Okay? Kung, kasi pag nag-design tayo ng something, right? Tayong mga chemical engineers, if we design something, it should be cost effective. Sa process control, it can maximize the use of something while minimizing the environmental constraints, while minimizing the operational constraints. So parang win-win talaga siya. Nagamit mo na ng todo yung mga chemicals at saka na-minimize mo pa yung mga operational constraints. So that is economics and it is given as an incentive to chemical process control. Okay? And here I have also discussed to you why chemical engineers control the process, right? We have to ensure safety. We have to ensure product specification based on what we desire. We have to ensure that we are following the environmental regulations and we have to minimize operational constraints and it should be cost effective, right? Yun ang ginagawa ng isang chemical engineer. Any questions? May question ba? Okay. So we move to the design aspects of a process control system. Okay. So these are some of the terms that you will encounter as we go on sa ating lectures, as we go deeper sa process dynamics and control. We have variables, okay? Since we are to design, we are to control a system, we need to mathematically represent your system, okay? So, kailangan natin ng variables. And that variable, kailangan din natin i-specify if it is input or output. Kapag input siya, is it manipulated or disturbance? Kapag output siya, is it measured or unmeasured? So, anong ibig sabihin ng mga yan? So, input variables, it denotes the effect of surroundings to the chemical process. So, papunta sa ating process. Output variables, it denotes the effect of chemical process to the surroundings. So, from the process to the surrounding. So, that is input and output variable. Under input variable siya, oo. Is it manipulated or disturbance? Ano ba ang manipulated? Manipulated variables or known as the adjustable, their values can be freely adjusted by human operator or the control mechanism. So, pwede natin siyang i-control. Okay? Pero yung disturbance, you cannot control them. It can be a natural phenomena or it can be galing sa feed. Okay? That is a disturbance na kailangan nating i-minimize or kailangan nating i-eliminate. The main purpose of process control is to eliminate disturbances. Okay? And uulitin ko, disturbances may be natural phenomena or it can come from the feed. Okay? So, hindi naman natin makokontrol minsan yung feed. Okay? Next, if it is your output variable, if it is measured output variable or unmeasured output variable. This is important when you are to decide if it is a feedback control system or a feed-forward control system. Kasi, kailangan mong i-measure yung lumalabas sa inyong process. Right? So, what if ang lumalabas sa process mo ay temperature? I mean, a stream na kailangan mo ay temperature nung stream. So, yung temperature ba, is it measured output variable or unmeasured output variable? Of course, it is measured. Kasi kaya natin siyang i-measure gamit ang temperature transmitter. How about kapag composition ang gusto nating malaman sa output stream natin? Pwede din natin siya directly na ma-measure, but you need to attach your gas chromatography na equipment or analyzer, composition analyzer na equipment na napakamahal and very sensitive. Okay, so is it considered as a measured output variable or unmeasured output variable? It is still a measured output variable, pero parang naggagasto ka na talaga. It is not cost effective anymore kasi ang mga gas chromatography na equipment ay nasa parang laboratory lang talaga. Okay? And it cannot be installed sa mismong process kasi napakamahal and mabilis masira kung continuous siya. So, we resort to something na related sa concentration. Okay? So, how can we do that? Pwede tayong gumamit ng mga equations that can be related to concentration. Okay? And then, tayo na yung mag-compute kung ito ba yung lalabas na something and be related to concentration. Ganon. Okay? Nagigets ba yung pinagsasabi ko? Sana pa. Sana naman. Gets nyo. Okay? Okay, we have example here. We have a steered tank heater and a CSTR with cooling jacket. Can you pinpoint the output and input variable here sa steered tank heater? Can I call Miss Maayon? Magbigay ng isang input and output variable dito sa ating steered tank heater sa una. Miss Maayon. Magbigay nga ng isang input at isang output na variable dito sa steered tank heater. Guys, what's happening? Can I call Miss Erica Soriano? Can you open your camera? Parang wala naman na akong kausap pala. All of you, please open your camera.
Sir, sa input and output po yung FI po.
Input yung FI. Ano yung output? The output variable is your F, right? Ito yung, guys, sabihin nyo lang sa akin yung mga nakasulat na dati, oh. So, we have input variable na Fi. Meron tayong output variable na F. Okay? Another input is yung Ti. Output ay yung T. Right? Ano po yung isang input? The feed stream. The feed concentration of the feed, the steam feed. Ay the FST dito. Yun lang, guys. That's the input and output variable. Now, yung Fi, is it a manipulated variable or is it a disturbance? Yung Fi, is it manipulated or disturbance? Based on the figure.
Manipulated, sir.
Manipulated. Is it really manipulated?
Yes, sir,
Dito sa
kasi pag
figure.
feed po.
Kasi,
Ang feed po pwede mong i-adjust freely, sir. I think.
okay. Tama ka. But dito sa ating mismong picture, can you see something na pwedeng pag-adjustan nung feed? Wala tayong valve. That's why yung F dito sa feed, dito sa ating picture is not manipulated, kundi disturbance. Okay? Ang ating only manipulated variable is the steam feed. Okay? Because we can close and open. We can measure the pwede nating i-limit kung ilan ang papasok na steam, ilan ang lalabas na papasok na steam. Okay? So, feed I is a disturbance here. Okay? It's not general. Okay? How about yung TI? Is it a manipulated variable or is it a disturbance? Miss Lawrence?
Sir, disturbance din po.
Disturbance din. Okay? So, hindi mo kasi yan makokontrol. Okay? Next, let's see dito sa ating CSTR. Alin dyan yung mga input? Input muna. Meron tayong TA, meron tayong TI, meron tayong FI, and we have coolant still. Alright? Yun yung inputs. The outputs are yung CA, the temperature, and the product flow rate, F. And then we have the flow rate of cooling water na lumabas na, and flow rate, temperature of the cooling water na lumabas na. Okay? And you cannot see any manipulated variable here, the picture. They are all disturbances, yung mga inputs. Okay, how about sa product? Can we say na lahat sila measured output variables or unmeasured output variables? Hmm?
Sir, siguro po sa
Okay.
temperature, pwede pong measured. And then dun po sa concentration naman po, pwede rin po gaya po nung na-mention niyo po kanina, using yung mamahaling device. Sa flow rate din po siguro pwede din pong measured if ewan.
Yes. Oo. So, temperature and flow rate, yun yung talagang measured kasi pwede mo lang gamitin ang Venturi dito sa flow rate. Ang temperature naman, diretso is temperature transmitter. Yung CA, it is debatable. Pwede siyang measured, can be directly measured, pero if you think of it as an engineering mind, it is not cost effective. So, kapag sa real world, I mean, theoretically, okay, yung concentration here, it can be measured directly. Pero sa mismong process na, or mismong industry, walang nag-a-attach ng gas chromatography or yung mga mamahalin na composition analyzer sa mismong planta. Okay, so it can be treated sa industry, it is treated as unmeasured output variable. Naintindihan? Okay. So these are the terminologies na parang yung iba na nabanggit na natin, yung iba ay babanggitin pa lang. Okay? So we have this term na process. Ang definition niyan, what's happening. Okay? Alam nyo na ang process, right? Let's have an example sa process. It can be, for example, taking a shower. That's a process. Second is driving a car. That's also a process. Next na term is the controlled variable. The definition of that is the one you want to set a value. Okay? Sa taking a shower, ano yung controlled variable dyan? It is the temperature. Gusto mong i-control ang temperature kapag nagtitake ka ng shower. Okay? And then kapag nagdadrive ka ng car, gusto mong i-control ang speed. Of course, there are lots of controlled variable when taking a shower and driving a car. Pero isa lang muna ang kinuha natin, which is temperature for taking a shower and speed for driving a car. Set point. Nasabi ko na tong set point kanina. The definition of that is where you want the controlled variable to be. Saan ba yung, for example, yung temperature, saan mo siya dapat, kung ilan or ilan ang temperature na gusto mo. Ganon. Yun ang set point. Okay? Okay. Kung sa example ng temperature, yung comfort natin na temperature, of course. And then sa speed, yung speed limit na gusto mo. Okay? That is set point. For sensor, the definition of that is what you use to measure the controlled variable. Sa controlled variable natin, ang temperature, we can measure that using your skin. Kapag nagtitake tayo ng shower, ano ba yung sensor natin? Yung skin. Okay. When we drive a car, ano yung sensor natin? It's the speedometer. It is something that you can measure. It is something you use to measure the control variable. Controller. Ito yung parang main. Controller, okay? The definition of that is compares sense value of controlled variable to set point and decides what to do. Okay? Kung ano ba ang gagawin mo? Kung bababaan mo ba yung temperature or tataasan mo pa? Depende sa kung anong gusto mo. And sa taking a shower and driving a car, ang controller ay kayo. You or your brain. Okay. Also have your manipulated variable. Okay. Definition of that, what you adjust to change the controlled variable. Ano yung controlled variable natin? It is temperature for taking a shower. Ano ba ang i-manipulate nyo para ma-change ang controlled variable? Ano? For taking a shower, ano yung i-adjust nyo para mapalitan or you can change the controlled variable? Devon,
Sir, ano po, yung valve po, yung valve po ng heater.
the flow rate of hot water, hindi yung mismong valve. Variable. Okay. When we say variable, ito yung parang kasali talaga sa process, hindi yung hardware. Okay? Sa ating, when driving a car, yung manipulated variable, yung gas flow of the system. Kung tatapakan mo ba ng sobrang alalim yung accelerator mo or konti lang to regulate or to control the gas flow. Yung sinasabi mong valve, okay, that is the actuator. Okay? Actuator, what you use to change the manipulated variable. Sorry, hindi ko nalagay. It is what you use to change the manipulated variable. Ito na yung dito sa when you're taking a shower, you can use your hand, your knob, your valve, the valve position. And then yung actuator naman sa driving a car, it is your gas pedal. See the difference? Kita niyo ba yung difference ng manipulated variable sa actuator? Yung actuator, yun yung hardware. Ha? Disturbance. Ito yung ayaw natin, yung disturbance. So, the definition of that is what causes the controlled variable to leave the set point. So, ano yung mga anticipated na mga variables na pwedeng mag-disturb sa taking a shower when you want to control the temperature sa shower ninyo. Okay? Una is your flow rate of the cold water. Bakit? Maybe it has something to do with the pressure nung household water system. Okay, paano kung may gumagamit na ibang tao ng water system ninyo? Maybe lumiit yung flow rate na papainitin. So, ibig sabihin, mabilis uminit. Diba? Kung mabilis or kung mataas naman ang pressure sa water system ninyo sa bahay, walang gumagamit, ikaw lang ang gumagamit, at napakabilis niyan, mas matagal na uminit ang inyong water. Kung i-full nyo, parehong full ang pag-open ng water. Okay? For driving a car, yung disturbance na pwedeng mang-disturb, okay, sa CV to leave the set point ay yung, for example, someone crossing the street. So, imbes na yung set point ko ay 60 kilometers per hour. Nagmumotor ka or nag-drive ka ng car, 60 kilometers per hour yung gusto kong speed ko hanggang sa bahay. Pero may disturbances. What if traffic? Aalis ka na sa set point mo, baka bababa yun ng 20 kilometers per hour. Someone crossing the street, alangan naman ungguin mo. So you need to stop. And those are the disturbances. Okay? Nagigets ba kung ano yun? Nagigets ba yung mga disturbance, actuator, manipulated variable? Gets?
Yes, sir.
Okay. All right. So, I will give you later on. I will give you now pala a seat work na ipapasa nyo sa ating first meeting, F to F. So, 2 weeks from now, doon nyo lang ipasa. This is your number 1 na seat work, handwritten lahat ha. You can screenshot nyo to. Screenshot na ba?
Yes, sir.
Na yan. This is number 2. Yan. Think of a process and determine which is controlled variable, which is the set point, sensor, controller, manipulated variable, actuator, and disturbance. So kayo ang mag-set kung anong process. Okay? It can be process from your daily routine. Ganon. Okay? Give at least 2 processes and then determine which is the controlled variable, set point, sensor, controller, manipulated variable, actuator, and disturbance. Okay. Okay, una yung development. So, punta tayo dito sa ating illustrative example. Okay. This is kumbaga typical na problem, typical setup sa mga processes sa industry is a mixing process or blending process. Okay? Can you see the figure? Is it clear? Kailangan ko bang palakihin? Kita naman. Okay. So this illustrative example will let you better understand, or this example can show you the relevance of process dynamics and control. Okay? Dito sa example, you can better understand the concept of process dynamics and control. All right, so we have a system here. We have a process here, a mixing process where you mix stream A, stream 1, and stream 2. Okay? Sa stream 1, you have mixture of A and B. So, hindi mo alam kung ano yung concentration ng A, hindi mo alam kung anong concentration ng B dito sa stream 1. Okay? Dito sa stream 2, we have pure A. So, ang concentration for A, X2 is equal to 1. Okay? Okay. Yung X1 dito, it will tell you about the composition, percent composition of mixture A. W1, it is the flow rate of stream 1. Okay, X2, it is the composition of A, which is 1, kasi sabi pure A. W2, it is the flow rate of stream 2. We have a control valve here for stream 2. It is mixed, and we have an overflow line where the product is going out. We have X as the product concentration, and we have W as the product flow rate. Okay. So, during steady state scenario, we want to solve, okay? We want to know what is the final concentration and what is the flow rate of the product, diba? We are more interested to that kasi ito, it is given. Given tong dalawang to, and this is a blending problem. So, ang control objective natin is to know what is the concentration and the flow rate of the product. So, kung ano yung X, ano yung W. Okay? So if we are to write the overall material balance around the tank, okay, OMB, we have 0 is equal to W1 plus W2 minus W. Yung bar dyan, that indicates steady state. Okay? So this is a general formula. Yung rate of accumulation is equal to in minus out plus generation minus consumption. Maalala nyo pa yung formula na yon? We have rate of accumulation is equal to in minus out plus generation minus consumption. Okay. Dito, sa equation na to, alin yung in? Ito yung in, yung dalawang to, right? 0 ang ating rate of accumulation. Okay, because it is steady state. This is in. Yung W na to, this is out. Wala tayong generation and wala tayong consumption kasi walang reaction na nangyari. So, hindi tayo naka-generate ibang mga component. At hindi rin tayo naka-consume ng component because we are assuming it is just blending. Okay? Walang reaction na nangyari. Walang na-consume, walang na-generate. Gets? Okay, if we write the component of A balance, we have W1x1 plus W2x2 minus WX. Okay, so what should W2 be? Okay, to keep X at set point XSP. So yung XSP, ito yung set point natin. What if gusto ko na may certain na value ang X na ito? So ano dapat ang flow rate ng W2 para ang concentration ng A ay yun yung gusto ko. For example, gusto ko yung concentration ng A ay 99%. Okay? Since pure A ito, okay, 99% A, ito kasi sa stream 1, we have mixtures of A and B. This can be, kumbaga, may time na siguro mas marami ang A, may time na mas marami ang B, and continuous siyang nagfo-flow. Okay? So, anong gagawin ko para taasan ang aking product? Kailangan kong i-adjust ang flow rate ng stream 2 kasi pure A naman siya para ma-achieve ko tong 99%. Gets? Gets ba? Guys, gets ba? It is important na mag-oo kayo o hindi. Okay, gets. Okay, very good. Okay, so gets nyo na ano dapat ang flow rate nung stream 2 para makuha ko itong set point na gusto ko. Okay? So if we substitute W, X, and X2 in component A balance, we can get this equation. Okay? We can get W2 is equal to W1 X SP minus X1 over 1 minus XP. So just do this and then you can arrive to this answer. Okay, so this will be our control law equation, or it is our model equation. Okay, gets? All right. So what if dito, suppose x1 varies with time. Okay, ito naman talaga ang mangyayari eh. Suppose X1, nagbabago ang X1 with time. So we will be dealing here dynamics. Okay, kung steady state lang siya, parang ang bilis lang ibahin, ang bilis lang i-control. But what if we deal with the dynamics? So, ang tanong dito, how sure or how can we ensure that the outlet composition X is equal to the set point that we want? Okay. So, ano yung mga gagawin natin? May 4 tayong pwedeng gawin para ma-achieve ito. First, we measure the X. We measure X here. We measure X and adjust W2. Diba? So, malalaman natin kung ano yung X muna. For example, ang X ko dito nung lumabas siya without any intervention ay 90%. Pero ang gusto natin, yung EXP, XSP natin is 99%. So, i-measure natin to 90%. So, anong gagawin ko? Tataasan ko yung flow rate ng A. Flow rate, tataasan ko yung W2 para ma-achieve itong 99%. Pwede natin gawin yon. Next na pwede natin gawin, we can measure X1. I-measure natin kung ilan ba yung pumasok. For example, ang pumasok na X1 natin ay 40%. Okay? I-measure natin to, tapos i-adjust natin tong W2 para kapag mag-combine na silang dalawa, 99% A na siya. We can do that. Okay? Next, of course, we can do both. Measure natin both yung X and X1 and then adjust accordingly yung W2. Another one na pwede natin gawin ay i-enlarge yung tank. I-enlarge or paliitin. Pero this is, kumbaga, not possible kapag running na yung system. Kaya mo bang palakihin or paliitin yung tank mo na talagang magic o liliit ka, lalaki ka? Can you do that? No, but it is possible for the objective to control or to achieve the set point that we want. Okay, the set point that we want is 99% composition of A, right? Pero yung pumapasok ay napakaliit. So anong gagawin natin? Pwede nating paliitin yung tank para mabilis maging 99%. Diba? Okay, pwede yon. Pero yung talagang possible lang sa kanila yung tatlong to. Okay? Nag-imagine lang ako dito na pwede kong gawin na i-enlarge at palaitin yung tank para ma-achieve ko yung gusto ko. Pero it is magic. Okay? Now, if we choose option 1, paano ang kanyang control system? If we choose option 1, what will W2 be? Okay. So, it can be if it is subjected to dynamics kapag X with the function of time, with respect to the function of time, it is less than the set point that we want, we need to increase W2. Diba kasi konti. Hindi mo na-achieve yung set point mo, right? And then, kapag sobra-sobra naman sa set point mo, itong xt, okay? X with the function of time, okay? With respect to time, we have to decrease W2. Okay? So, dito sa ating control system, okay, we need to analyze, sabi dito, measure X and then adjust W2, right? So, i-measure ang outlet stream gamit ang composition analyzer o transmitter, okay? And then, itatapon niya yan sa ating controller, okay? Dito na rin natin ilalagay ang ating set point na 99%. So, i-compare nung controller yung actual na composition dito at sa set point natin, saka siya gagalaw kung gaano ka-tight or kaluwang itong pag-control nyo dito sa valve to control the W2. Okay? Ganyan ang control system when we want to measure X and then adjust W2. Okay, gets? Gets ba? Okay, so this is also an example of your feedback control system. Feedback control. Kasi na-disturb na muna bago ka gagawa ng move. Okay? So from now on guys, itong may nakikita kayong broken lines. From now on, ang ibig sabihin niyan ay electronic transmission lines. Okay? Kapag broken line, ibig sabihin electronic transmission lines. Okay? And then, okay, so it is still, if we want to know the value of W2 with respect to time, it is equal to W2 plus the deviation. Okay? Deviation of your itong nakuha niyang composition at saka sa set point mo. So parang this is called the deviation. Okay? Ito yung ginagawa ng controller. Yung KC, this is what we call gain. Later on sa ating mathematical modeling, we will tackle about gain. Okay? So tanggapin niyo muna tong equation. This will be our control law equation or your model equation. Okay, gets? Gets ba? Okay. What if we choose option 2 to control the process? Okay. If we use option 2, what will W2 be? Okay. Okay. So hint here, we can use the component A balance. So, this is familiar, right? Ito yung when we dun sa unang kumbaga sa steady state, pero hindi na siya dito sa equation na to, hindi siya steady state because we will be dealing with change in time. Okay? So paano nangyayari dito sa control system natin? Okay, una, pine-measure natin yung X1, right? Sa option 2 natin, measure X1 and adjust W2. So we need to measure X1. For example, ang X1 natin ay nasa 40%. Right? Sasabihin naman nitong composition analyzer na 40% lang siya. Sasabihin niya sa controller. Tapos ang gusto natin is 99%. Sasabihin niya, o i-compare niya dito and then sasabihin niya na dito na kailangan ko ng something sa'yo para maging 99% kapag nag-mix na silang dalawa. Ganun ang ginagawa ng composition controller. Okay? So, tinatapon niya yung signal from the composition analyzer na 40% lang ang pumapasok. Okay? Pero ang gusto ko is 99. So, magpapasok ka ng ganitong composition ng flow rate. Okay? Magpapasok ka ng ganitong flow rate to achieve yung gusto ko no 99%. Ganun ang automatic control. Okay? So, do you get it? Gets? Okay kayo ha. Walang tanong ha. So, this control system is an example of feed forward. control. Okay? So, hindi siya na-upset. Hindi na-upset tong system. Paglabas niya dito, 99% na. So, yung EXP ay nagustuhan ko na dati pa. Hindi ko matitikman ang pangit. Okay. Diretso na maganda yung gusto ko dito. Ganun ang feed forward. Pero it doesn't mean na laging feed forward dapat. Okay? May advantages and disadvantages of your feed forward and feedback. Okay? Sa feedback control, ang disadvantage nun, of course, na-upset na muna yung system bago mo makorek. Pero ang advantage ng feedback control is na-correct na siya, so sigurado ka na tama na yung lumalabas. Okay? Ang feed forward kasi, you just anticipated. Okay? What if itong 40% ay hindi eksaktong 40%? Paano kung nasa 37% yan? Okay? So, your XSP might not be exactly 99% kapag feed forward control system. Okay? Gets? Sana gets ha? And then yung option 3, we have measure both X and X1 and adjust accordingly, W2. So, walang control system for that. Okay? I just anticipated yung dalawang to. Okay? Gets ba? Any question? Have any questions so far? Okay, tomorrow, kayo kasi ulit yung klase ko, no? Parang we need more examples pa muna before tayo sa mathematical modeling. And of course, before yung mathematical modeling sa ating course syllabus, you need to know about Laplace transforms. At hindi ko na yun i-discuss, kayo na bahala doon. Kasi it's just a review, hindi naman kayo first year. So, kailangan kayo lapang mag-review no Laplace transform. You need that for mathematical modeling and theorization of mathematical models later on. Okay? Okay. All right. So, can you please open your cameras? Mag-picture tayo. Isa pa. Smile. Smile lang. Last one. Okay. Thank you so much. Kung walang tanong, siguro we can end the meeting. Do you have any question? Huwag kayong mahihiya. Ang gamit kong book ay kay Stephanopoulos at saka kay Seborg. Okay, pero mostly ang gagamitin nating book ay kay Seborg. If you want additional information, okay, kasi yung sinasabi ko sa inyo, it is how I learned the topic. Gusto nyo kung gusto nyo din na i-recap lahat yung sinabi ko, you can read the chapter 1 and chapter 2 of Seborg, the Process Dynamics and Control by Seborg. Chapter 1 and chapter 2 yun. Okay, it is introduction to process dynamics and control. Okay?
Sir, ano pong ed po nung kay Seborg na gamit niya, sir?
Ano?
Sir, anong edition po?
Edition, bakit kailangan malaman? Pareho lang laman nun. Hindi pa siya masyadong na-edit. So, you can use siguro up to 2nd edition. Pero, ang latest edition of Seborg is 4th edition.
Thank you, sir.
Okay. Ano pa? Anong? Tanong pa? Okay. So, kung wala na, class, you are dismissed. Thank you for listening.
Bye, sir.
Thank you, sir.
Goodbye.